Hi, you're right. Welcome to your lesson on pressure in gases. So starter for this lesson, 3 questions. What is the moment of a load with a weight of 70 newtons on a lever but 2 meters away from the pivot? Number 2, how far from the pivot would a person weighing 35 newtons need to be to balance the moments? So think about a seesaw. Number 3, what is the work done on a shovel where the force is 10 newtons and the distance moves is 50 centimeters. Okay, so think back to your lesson on moments. The last 2 lessons have been on moments, and answer those. Pause the video to do that now. Okay, so answers here. Number 1 was 140 newton meters. 2, 4 meters. 3, 5 joules. Remember, work done is calculated in joules. So gas pressure right now in this classroom or wherever you're watching this video, there are gas particles moving and colliding. They are always moving and they are always hitting you constantly. When they hit you, they cause a force. This causes a pressure on you. So we're all under pressure all of the time. Depending on where we are, that pressure level may change, but we're all being pushed in from the outside. So it's the same for everyone in the same place as you. It's the same on every part of your body. So you're constantly being pushed in around you. The things that affect it are the quantity, density of air particles and the temperature. And we'll look at how those two things affect it later on. So higher you go up a mountain, the less pressure there is. Why? Have a think about that for a minute. So think about the quantity of air particles, that picture on the top left showing the birds representing the particles. Think about what might change. So as you go up a mountain, there are fewer air particles. They are more spread out. So there is less pressure because there's less particles that are going to be hitting you constantly. Whereas at ground level, there are lots of particles that are putting an even pressure on you all the time. So this is the first one that affects air pressure, the number of particles. So at ground level, we would expect a normal amount, whereas up a mountain, very small amount. If we were to go under the water, deep under the sea, then there would be even greater pressure. So less particles higher you go, less force is exerted on you, therefore there is less pressure. This is why a balloon which hasn't been blown up fully is crinkled. It has a small amount of particles inside, so it has a low pressure. You can see the balloon, the second one in there, all crinkly, because it's not been inflated as much as the one on the far right, which has lots of particles inside pushing out. Obviously, if we were to continue putting more and more air into the balloon, pressure would increase to a point where the balloon would burst. So the particles are moving and colliding, which exerts a force on me. Can you tell me the pressure difference if I showed you this picture? So what would the pressure difference be? So up high on top of the mountain would be low pressure, down at ground level would be higher pressure. So because there are less particles higher up the mountain, there's a lower pressure. So we've spoken about the quantity of particles, and now we're going to look at the temperature. So discuss or think about what happens to particles when they are heated up. What will happen to gas particles when the temperature is increased? Think about your particle theory. Okay, well, what happens to particles when they are heated up? So we know that as particles get heated up, they begin to move faster. Temperatures increase. Faster particles means more pressure. So when hot day, you're under more pressure because particles around you have more energy. Very cold days, you're under less pressure because they don't have as much energy. So we know that the particles in a gas move quickly in all directions randomly, but they don't get far before they bump into each other or off the walls of their container. And when they hit the walls of their container, they cause pressure. More particles that hit the walls, the higher the pressure. This is why the pressure in a tire or balloon goes up when more air is pumped in, as we know. Okay, so on the next slide there's going to be some pictures, some activities for you to complete. And there's also this question that I like to think about. So, did you know if you took a bag of crisps on a plane after takeoff, the bag would have expanded? Okay, so that's your extension. If you can use your knowledge to explain why it is that that happens. Okay, so we're going to look at the next page with the questions, and that's your challenge to think about before you do that. Okay, so here are your questions. There are 5 questions for you to work through. If you've got the worksheet with you, then that'll be easier. If not, you'll have to write down the answers on your book or paper. Pause the video now to do this. Okay, so purple pen for the first one. The particles inside the balloon, they are moving and colliding. The particles that you draw would look like they do at the top there. So we've got lots of particles moving randomly around in all directions, and they will be colliding. Number 3, why is the balloon inflated and staying that way? The particles are colliding with the walls of the balloon. This produces a pressure on it that keeps the balloon inflated. Number 4, what has the cold temperature of the fridge done to the particles? How are they behaving now? We can see it's slowed them down. So this was a balloon that was inflated properly and then put in the fridge. So it's brought down to a cold temperature and it slowed them down. Number 5, why has this caused the balloon to deflate? Tick the correct response. It's the top one. The slower moving particles produce less pressure on the walls of the balloon, so it shrinks. Okay, make sure you've purple penned, you've written down any corrections that you need to make. Pause the video if you need to do this. And then the extension questions. So if you took a bag of crisps on a plane, after takeoff the bag expanded. So as you take off, you're going to less pressure atmosphere. There's less pressure on an aeroplane. Less pressure on the outside of the bag means there is more pressure on the inside compared to the outside, so that's pushing outwards. If you were to go into less and less pressure, eventually the pressure inside becomes so much that the bag would burst. Okay, copy and complete this word paragraph. So pause the video to do this now. The keywords are at the top for you. Okay, so purple pen. Gases are made of particles that move fast. The force of the particles hitting the sides of the container causes the pressure. More particles means more pressure. Faster moving particles means higher pressure. Water liquid exerts less pressure than water vapor. When you open a can of Coke or any fizzy drink, you get this spray coming out of the top. So the reason that this happens is because there is more pressure inside the can than outside. So the gas quickly moves, which causes the spray. So that's the gas trying to balance between inside the can and outside the can. You know that they're pressurized because if you shake them up and open it, then it sprays out everywhere. But as a standard, when you open the can, you get this little tiny spray just as the gases balance out. Okay, this is a smaller demo that we would do in class, similar to the video which was on the Google form. If you're not watching on the Google form, you can have a look at these videos that show the same thing. And this is to show the pressure change in cans. So first off, which of these cans has more pressure? Can you explain? Should be a relatively straightforward one. So we know the can on the left has more pressure inside because the particles inside are at a higher temperature. They're being heated. Okay, and we know that temperature affects pressure. Higher temperature, higher pressure. So what we would do if we were doing this experiment is we would heat a can with a small amount of water inside until steam is produced, so we know that the water inside is boiling. Wait a few seconds, and then we're using tongs, because obviously the can will be hot, grab the can, tip it upside down into cold water. The reason we tip it upside down is because then the air inside cannot escape through the top, and we hope to see a rapid pressure change. So again, this is what we would do. So before the experiment, there was an equal pressure between the can and the outside. It's already been opened, it's empty, so there is air inside, there's air outside. Pressure pushing from both directions. As the can is heated, the gas is expelled, and then the water turns into steam, which increases the pressure on the sides of the can. So the pressure increases inside of the can. When it's put into cold water, the water vapor quickly condenses back to water liquid, which quickly reduces the pressure compared to the outside. So we know that gases are higher pressure than liquids, so as they turn back into a liquid, the pressure inside drops rapidly. And this causes the can to be crushed in quite a dramatic fashion very often. So use the words above each picture to explain that part of the experiment. Okay, complete this in your books or on your paper now. Pause the video. Okay, so to purple pen, what you should have, so for this first picture, you could say that the pressure both outside and inside is equal, it's balanced within and outside the can. Then as you are heating it, the temperature increases inside the can and the pressure increases inside the can. The walls of the can are being pushed outwards and inwards. Then as we turn it and put it into the cold water, the pressure decreases rapidly inside, causing a huge imbalance. The surroundings have a much higher pressure and they push on the walls of the can and cause an implosion. So they cause the can to collapse. Okay, this is the end of your video for gas pressure. There are a few other questions and tasks for you to complete on Google Form if you're completing it on there. And I'll speak to you in the next lesson.